Bismillahirrahmanirrahim. Assalamu alaikum wa rahmatullah. Welcome to this program where I will teach you how to convert from binary to decimal. Again, we have here the same stuff, that is model small, stack 100, and we got the daily segment here wherein we have the first message, that means enter a binary number. Maximum is 16 digits. You can put in to the maximum 16 digits. And equivalent decimal number is, this is the second message, because we have to convert from binary to the decimal. And if you try to input from the keyboard, say for example minus characters or maybe 2 3, because we have to input only binaries, that means 0 and 1, but maybe you put in 2 3 5 or something else other than 0 or 1, other than 0 or 1. So what should our program do? It should generate this illegal character message, and also ask us to try again, that we should go back to this input, enter a binary number, so that we could input the correct binary number. So here is the code. It's the main procedure. Here we are having the main procedure, and move ax at the rate of data. This is to initialize data segment, as you know. Put in ax to dx, then prompt 1, that means enter this message, enter a binary number. This message is shown on the monitor by the interrupt 9h of interrupt 21h, sorry, function 9h. You know these things. Then actually, to input a binary number, we call this procedure binary input. So this procedure will be called, so we jump to the procedure called binary input, that is this procedure. And this procedure will read a number in a binary form. Okay, this will store binary number in the bx, and it uses the main procedure. We know this thing. So jump, we say first statement, jump at the rate of again. That means we have to jump in here, because this error message, we will see this shortly. First thing will be jump at the rate of again. So this will, the first statement of the binary input here, it will jump actually to the at the rate of again. That means this position. At this position it loads CX16, because we could have a maximum of 16 digits. We can input 16 digits only, 16 ones or zeros, whatever, because our register is a 16-bit long. So we put 16 in the CX. We XOR BX to BX, that means we clear BX. When we XOR BX with the BX, it will clear BX. That means BX will have all zeros in it. Then actually we put move AH01H, or that means we want to input something. And there is a label here. We'll see later what will happen to it. But we will call the interrupt 21H to input a character. So you are inputting by this thing. You input a character from the keyboard, so which will be put into the AL, you know that thing. And now we compare that what you inputted, because we are also doing error checking here. Maybe you inputted some minus number, maybe you inputted something other than 0 or 1. We should generate the error message and loop back. So we are first comparing your AL, what is in the AL, that is what you have inputted from the keyboard, with the 0DH, that means carriage return, and compare with that. And if it's that, we say jump JE, jump if equal to 0DH. If whatever you have inputted is equal to 0DH, then go to the AND. And what is in the AND we'll see in a short while. That means 0DH actually means what? It is the enter. If it is enter character, it's okay. That means you want to finish. This is, if you have pressed the enter, that means that's all you want to input. That means you're finished with inputting. So we should go to the AND. So AND is here, wherein we finish this procedure and return back to the main procedure. But if it is not the enter character, maybe it is something which is below 0. So we are comparing AL with the 30H, that means 0. And if it is something you put in less than 0, then you should go to the error message. Because if it is less than 0, or maybe sometimes greater than 0, which we're checking here, then you should go to the error message and do it again. That's why I have put it error message on the top. Now we got it. That's why error message is here, because we display the error message and do the things again. So but first time, when you first time enter this, you should not print the error message. So first time around you jump to the again. That's why I put an error message here, because I want to loop it again and again. And jump is the because of this thing, I wanna skip for the first time around. First time when I enter this procedure, I would like to jump here, because I don't want to print at that time error message, because you have actually inputted nothing. Now if either whatever you have inputted is less than 0, or we are saying here greater than 1, 31H is the hexadecimal of ASCII 1. So if it is greater than 1 or less than 0, go to the error message. That means the message will be print like this message, error message, that illegal character, try again, and you will be again prompted, because when the error message is printed, okay, you will be again prompted. 16 will be put in ACX and BX will be cleared, and AH will be inputted with the 101H, and that means function interrupt 21H will be called to read a digit from the keyboard. That means you are prompted again to correct your input, because you have inputted either greater than 0 or less than 0 or greater than 1. So you should put something in between 0 and 1. That means either 0 or 1, because binary has only 2 options. So if you have not inputted the enter, that means you don't want to end, or you have not put any illegal binary character, that means less than 0 or greater than 1, okay, that means your character was okay, it was either 0 or it was either 1, then we should go this. So that character will be in AL, because 02H function, 01H function will work and put your data, but it will read digit from the keyboard and put into the AL. We AND AL with the 0FH. Now we are ANDing AL with the 0FH. What does that mean? That means because AL will have either 0 or either 1, so lower nibble of AL is retained and upper nibble is cleared. So 0, because a lower nibble be all 4, because this 0 is all 0. This 0 means 4 zeros actually, hexadecimal, and F means 4 ones. So what we are doing is we're clearing the lower nibble and putting what is in the upper nibble, and what is only having what is in the lower nibble. That's definitely either 0 or either 1. Then what we do is we actually want to put that AL into the BL, and what you have inputted, for example, you input 0, you input 0 like this, you input 0, okay, next time you input 1. So first this 0 should go a bit left like this, and the next what you put should be put here like this. So we are actually shifting BX left, so that whatever you input first, that goes to the most significant bit, and whatever you're inputting next goes here. So whatever you're inputting again goes here, because this will be shifted again and again to the left and left. So that's what we're doing here. And then what we do, we OR BL with the AL. That means, what does this statement mean is, whatever was in the BL, because BL already have, because for the first time around, if, for example, you inputted 1, okay, so in the BL it will be 1, in the AL it will be 1. Now when the second time around you put again, for example, 0 in the AL, so it should be 1, 1 first time in the BL. Now you are inputting 0, that means AL will have 0 in it, so you're trying to put that 0 in the BL, but BL should retain its value. So BL is, for example, 1 and other all those because 7 zeros it will be having 7 zeros, because 1 2 3 4 5 6 7 zeros, because it's the 8-bit register, it's having this thing in it, okay. and next time around AX will have, for example, all zeros, or maybe 1, again 1. Okay, it will be again 1. Maybe we are inputting again 1, okay, into the AL. Now this is my BL. Now AL will be having again 1, so it will be like this: 0 0 0 0 0 and 1. Again AL and 1. When I OR this thing, this will definitely give me the this will not reflect the actual value, because I have to first shift this to the left. That's what it's doing. So this 1 moves here. Okay, so what happens is when we shift it to the left, this 1 will move here. It actually goes like this. This will shift, this is gone, and here comes 0. So 1 will shift to the left, and now I OR this BL with the AL. When I OR these two, what will be the result? The result definitely will be like this. It will be 0 0 0 0 0 0 1 and 1. So now my BL will contain the previous one that goes onto the most significant side, and the next one which is coming in here. Understand? Maybe next time around, again the next time around, we input AL as a 0, then this will again shifted. These two will come here, here and here, and at this position will be 0, and that will be again ORed with the AL. Whatever will be at the AL's least significant bit, that will be retained here in the BL with this OR statement. So I probably think you got it. So definitely BL this time, the first time around, it will have what is in the AL, that will be going to the BL. Now I'm again doing this because I have to repeat this. I have to repeat this. So I'm loop at the input. So input, where is input? It will go here. Okay, it will go here, and loop automatically decrements CX also. So it will decrement CX. So CX becomes 15. Are you getting me or not? So when I can do, why I'm doing 16, because I can input at the most 16 digits, because I have the 16 bit space. Now maybe I want to print only 7 1 1 1. I don't want to input all the 16 digits. What will happen then? When I input a second time, for example, here, its CX will become 15, okay, but it will be again compared here. So again the same story, but when it's a third time, it will again looped. Third time 1, again, okay, fine, I'm done with the 3 1. Now I don't want to input again, so I will input enter. After 3 1s I will input enter. When I input enter, it will be chuck in here that, okay, compare AL 0 to 8. Oh yeah, it's enter. When it's enter, so it will not be done here, it will go to the end. That means it's like in the switch statement or whatever we use in the C language, we use break. It goes break out of the loop. So even though we could have if I have only input 3 times, I could have more. I have more 13 loops, but I'm not having all those 13 loops, because I'm going to break it from here, because I'm inputting enter. So if you want to get out of the loop, so you can go by putting enter, by only pressing enter without pressing any key, and it will go out of the loop. It will go out of the loop where here. It will go to the end. So at the end of this, the BX will have the number what you want to input. For example, you want to input 1 1 1, when 7, that will be input here. Understand? Or you could input all ones, 16 digits. You could input 16 times, 16 digits, I will say. Or maybe you could, because I'm storing in the BX. BX is the what it's called. It's a 16-digit register. So we could have 16 digits here, all 16 ones, or combination of zeros and ones, whatever a number we can come out. That's a binary number. And now on, we want to make that binary into the decimal. That's my program actually. So I will go back, because this is return statement will get us back to the main procedure here. So this is the this was the call binary input. Now on, I have done with the input. Now what happens is I want to prompt second. There's the prompt second, that means give message second that equivalent decimal number is. Now definitely I will print the message that equivalent decimal number is by this piece of code. You know this thing, no explanations. and then what should I go? I should go to the some procedure which will print me in decimal, is it or not? So what I'm doing first is I'm storing the bx, because our number is in a bx. Okay, our number is in bx. I want to put that into the ax is equal to bx, as you can see, and now ax will have a number, and I call out decimal, so it means output into the decimal. So I'm having the ax which is having my value, and I'm calling out a decimal which will print me the decimal value. Why is that? That's here, output decimal procedure. So input here is the ax register, because we have in the ax register that value, and output is none, means we don't want to output anything to any procedure and returning something or like that because we want to print here in the decimal. What is in the ax is a binary. We will like to print that into the what's called as decimal. The decimal number will be inputted. Again, we're pushing bx, cx, and dx's registers are pushed on stack, so let's preserve them. And compare x is 0. Maybe your ax is 0. Or what happens here is we are actually checking whether it is 0 or greater than 0. But if it's less than 0, that means it's a negative number, then I should not do the usual code, I should do something different. But if it is 0 or greater than 0 number, then I should go to the start, that's here. Okay, no, what is that? I should go to the start is here. Okay, here in I will clear first cx, counter I will clear in. I put 10 in the bx. For example, my situation is like this. Look here. If, for example, I have in my ax now 1 1 1 1 1. Okay, so 1 2 3 4 5. Well, this is how a lot of things I put in. I'll make it simple. I make it for example, it is 1 2 3 4 5. Maybe I will put it. Okay, this will be 1 2 4 8 16. 16 plus 15, that means it's equal to 31. So it is my 31 decimal actually, but the number will be like this. It's 31 in the ax. So I'm working on this. Maybe my input was this 5 ones, that means 31. So how will this binary 31 will be printed into the decimal 31 like this? So that's what we're gonna do here. Now what we are doing here is we are first clearing the cx. That's simple to clear it. If it has a previous value, just clear it. And maybe it has some previous values, clear it. Simple. And put 10 of the bx. Okay, because I'm going to divide this number by 10 repeatedly. Now this is a repeat label, which I will come back to it. Again, what we do is clear dx, because maybe dx has something else in it, so clear that as well. Now divide bx. Now we say divide bx, it automatically divides bx with the ax. We don't have to write ax here, because divide it has one operand into the ax by default, and so it's dividing ax by the bx. Okay, so whatever is in the bx, that is 10, and what is in the ax, that is this thing. So divide this by the 10, so it will be like this, 31 divided by 10. Okay, what is remainder? Remainder is 1 and coefficient is 3, is it or not? When you divide 31 by the 10, the remainder will come to be 1 and coefficient will be 3. So remainder goes to the dx, because when you divide, remainder goes to the dx, okay, and ax retains the coefficient. So what we are doing here is, because a remainder here, for example, if this number remainder is 1, that 1 is in the dx. When you divide, the 1 is in the dx. We are pushing that dx. We are pushing that dx. So in the stack, if we have a stack, that will have 1 in it. Okay, it will be like this. For example, this is my stack. For example, this is my stack. Okay, stack will have 1 in it. It's a stack has 1 in it. Okay, now what I am doing here is I'm pushing the dx, and that means the remainder into this stack, and increment cx. Cx is to be incremented, so cx was 0, it becomes 1, because when you cleared cx it was 0, now it becomes 1, cx is 1, and or ax with ax. What we are doing is, what is in the ax, just or it with the ax. I'm pushing the dx, and that means the remainder into this stack, and increment cx. Cx is to be incremented, so cx was 0, it becomes 1, because when you cleared cx it was 0, now it becomes 1, cx is 1, and or ax with ax. What we are doing is, what is in the ax, just or it with the ax, that means retain ax, simple. What is in a ax, that is to be retained, and because ax will have now what, if when we have divided actually here, ax will have 3 in it now, not 1, it will have 3 in it, so it will have 3 in it, and it will go to the repeat, but we are saying a journey, but that means jump to the label this thing if 0 flag is 0. If 0 flag comes to 1, then what happens is it will not go to the repeat. But this time around 0 flag is 0, because divide is not creating a 0 here. I will shortly see it will create a 0 here. Now this time around 0 flag is 0, so it will go to the repeat. Okay, so JNE means what? Jump to the label if 0 flag is 0. So equal, is it? Okay. So it goes to the repeat again clearing the dx, dividing bx with the ax this time has not the 31 but the 3. It will divide it with the that means it's only this time around it's only 3 in it, so it will divide it by 10. When 3 is divided by 10, coefficient becomes 0, so 0 flag will be set, and remainder is 3. Okay, that remainder goes where? Into the dx. Now we push that dx, that means 3 is put into the stack. So 3 is put in the stack here as like this. As you know, stacks grows actually downwards. Stack goes downward. This is the bottom of the stack, the top of the stack. So stack goes in the memory actual thing is it grows downwards. So it's the actual way of showing things, because now stack has a 1, then it has a 3. But 0 flag has been set because division created into the AX 0, so 0 flag will be set. It will not go to the repeat, it will come out of the loop. So what it will do is it will set output function 2 into the edge, and what it will do is it will start displaying things. That means it will pop dx. What is it? When it will pop, what will be in the dx? That will be 3. In fact, that will be the binary 3, not just like this 3. That will be binary 3 1 1. It will be actually stored like this. It will be, for example, it will be 1. Maybe I will take just a nibble 1 for a simple purposes, and 3 will be actually like this 0 0 1 1. In a stack, when the 3 like this is get out of the stack, so 3 is put in the stack here as like this. As you know, stacks grows actually downwards. Stack goes downward. This is the bottom of the stack, the top of the stack. So stack goes in the memory actual thing is it grows downwards. So it's the actual way of showing things, because now stack has a 1, then it has a 3. But 0 flag has been set because division created into the AX 0, so 0 flag will be set. It will not go to the repeat, it will come out of the loop. So what it will do is it will set output function 2 into the edge, and what it will do is it will start displaying things. That means it will pop dx. What is it? When it will pop, what will be in the dx? That will be 3. In fact, that will be the binary 3, not just like this 3. That will be binary 3 1 1. It will be actually stored like this. It will be, for example, it will be 1. Maybe I will take just a nibble 1 for a simple purposes, and 3 will be actually like this 0 0 1 1. Okay, so we're having 3 like this, 1 like this in a stack. When the 3 like this is get out of the stack, popped from the stack, so 3 comes out. So but we know 0 to H is printing only ASCIIs, so I have to convert back into the ASCII. So what I'm doing is I'm ORing this thing with the 30H. So when you OR this thing with 30H, actually this is here having 4 nibble 0 and this thing. So when I OR this with 30H, what will happen? You could see like this, because 30 is like this 0 0 0 1 1, and here all zeros. So answer which will come here is like this, because we are ORing this. It's written all ones, and it will be 1 1, then 0 0 1 1. So it will be 33. Okay, which is the ASCII of 3. So actually, if you want to print 3, you cannot give 3 to the 0 to H function. You have to give it 33, because ASCII of 3 is 33 in hexadecimal. So what you are giving is you're actually adding this 30 to it. So we are ORing it with the 3 0, so it will retain this side here, and 3 is here. So that is my 33 in ASCII. That ASCII is actually the 3 representation, so it will print me what? Interrupt 21 H only call, because AH has 2 in it, it will print 3. So it's printing 3. Then again loop at the display. It will loop again to the display, because loop again decrement CX. CX here was incremented twice. Okay, CX was having 2 in it, and we did this thing. Now that CX will be again decremented until it hits 0. So this display will be called loop again unless CX is 0. But this time is a 2. Now decremented becomes 1. Again this thing. Now pop DX. What is in a stack? Put that to the DX. Stack will have now 1 because this is popped already. Now we have to pop this. That is 1. Okay. Now this will be having 1 here, and again we change that to the ASCII by ORing with the 30, same procedure, and it will print me 1. So 31 will be printed, and it will pop those registers and return back. So when it return back, it will return back where? It will return back to the main procedure, that is somewhere above. That is here, because we had called it here. So it will return here, and here is what? This is return to control to the DOS, because we successfully completed our program. So if we look at, if we try to run it, what's the name of this program? Bin to deck. So I will say tassel bin to deck. Okay, no errors. T-link bin to deck, and now run it. Bin to deck. Now see, enter a binary number. Maybe I have put something like 4, but it is illegal character. It's telling me no, you cannot input 4 because my valid inputs are 0 or 1. So I cannot. Maybe I will input minus. It's again not printing because it's going back. It's this part of code. It's doing this part of code because it is chucking. It is chucking, for example, here. What is that? Yeah, here. If I enter, it will go end. It will end this program. But if it is less than 0, it will go to the error message. If it is greater than 1, it will again go to the error message. So it can only print me when I print something between 0 and 1. That means 0 or 1. Maybe I print 1. What was my number? 5 ones. Okay, 1. Okay. Again, because illegal character try, so I said 1. Okay. Then it's again waiting for my input. I say 1. I say 1, 1. So 4 ones and 5 ones. That was my 31. And I say enter. And equivalent decimal number is 31. It's giving me again correctly. So same procedure what we did. That 31 will be printed by the stacks, actually putting things on the stacks and then doing things. I think this is enough for the explanation. Maybe you watch it 2-4 times. Just first write this program on your copy. Write this program on the copy, then watch 1 or 2 times, maybe more than 2 times, and you'll be fine. So take very good care of yourselves. Ma salama.